In this video, I'm going to talk you through how to use the method of completing the square. You want to use complete the square when you're trying to solve a quadratic, so something whose highest term is x squared. And the second thing you want to look for is when the leading coefficient, so the number that's in front of your highest power, which in this case has to be x squared, is a 1, and when the middle term's coefficient is an even number. So an example, if you had x squared plus 6x plus 3 is equal to 0, and you're trying to solve something like that, you're looking for the middle term, in this case the 6x, that to be even. So that would be an excellent case when you could use complete the square. Now keep in mind, complete the square is not the only method you could use. You could also use the quadratic formula, but we've talked about in class how sometimes complete the square is just going to be a little bit more efficient once you get the hang of it. So let's go ahead and solve the x squared plus 6x plus 3 is equal to 0. Now when you look at this quadratic, how you can tell initially is when you look at this, it's not factorable. So there's no numbers that will multiply to give us a 3 that will add to give us a positive 6. We need to do something else. Notice that the number in front of x squared is a 1, and then the 6x is even, so we can go ahead and use complete the square. So to start it, you got to subtract over the constant to the other side of the equation. So you're left with x squared plus 6x plus, now I like to draw a box. I'm a very visual learner, so sometimes the box helps, because that's where we're going to find a new number to go in that box. On the other side we have a negative 3, and whatever we do to one side we have to do the other, so a plus box on the right side. From here, what you're going to look for is this middle term, the 6x, and you're going to take half of that term, which is why we want that number to be an even number, and square it, and it goes in the box. Same thing over here, positive 3 squared in the box. Now I'll show you kind of the middle two steps just to prove to you why this method works and how we can take the shortcut later on. But if we write this out, x squared plus 6x plus 3 squared is 9 is equal to, then on the right side we have negative 3 plus 9, which will give us a positive 6. Now when we look at just the left side of this equation, the x squared plus 6x plus 9, now that polynomial is factorable. If you ignore the 6 on the other side and we just look at the x squared plus 6x plus 9, this will factor into x plus 3 times another x plus 3 is equal to 6. And then we really don't need to write out both of those x plus 3's. We can rewrite it as x plus 3, the quantity squared, is equal to 6 on the right side. Now when I showed you this first in class, we talked about how these middle two steps, if you want to do them, because it makes you feel more comfortable, go ahead and do them. But really we can take a nice little shortcut when we do this from this step here down to this step. And you do that by looking at the term that has the square on it here, and this term that has the square on it, so the x and the 3. Notice we have an x and a positive 3 in the set of parentheses there, and then the square that they share up here becomes a square down here. So once you get used to that pattern, you can kind of make that quick shortcut, which is why I think complete the square is a little bit quicker than the quadratic formula when complete the square is a good method to solve it. Alright, last step, we're going to square root both sides, and we end up with x plus 3 on the left, and on the right we have plus or minus the square root of 6. And last but not least, we need to take that 3 and move it over. So our final answer for this is x is equal to negative 3 plus or minus the square root of 6. Now if the quadratic that you started off with initially was not factorable, you'll usually get, or you should get, some sort of irrational number in your answer, so a radical that cannot be taken the perfect square of, and or you'll get some sort of imaginary number. So let's try to come up with an example where we'll find an I in our answer. Alright, so if you take a look at this quadratic, first check and see if it's factorable. We're looking for numbers that multiply to give us 19, that add to give us a negative 4. I don't quite think that's going to happen. So next thing we look at, the first term is a 1, So complete the square, so far so good. And then this middle term is an even number, so again, complete the square is going to be an excellent method. So we're going to start by moving over the 19. So we're left with x squared minus 4x plus a square is equal to negative 19 plus a square on the right side. Taking half of the middle term. Now pay attention to the sign. We have a negative 4x, so half of negative 4 is negative 2 squared. And same thing on the other side. Now you might think it might not make a huge difference, and on the right side of the equation it doesn't, because negative 2 squared or positive 2 squared, either way is going to give you a positive 4. But on the left side it does make a difference, and this is where when we go to write our answer in the sets of parentheses, if we take that shortcut on this one, we're taking the x. Now here, we're going to take that negative 2. And if you ignore this sign here, you might make the mistake of putting a plus sign in the middle in the next step, so just pay attention to the signs as you write them. And on the other side, we have negative 19 plus 4, so we really have negative 15 on the right side. We can go ahead and square root both sides. So x minus 2 on the left. Now on the right, this is where we're going to run into, we have a negative underneath the radical, so we're going to bring it out, because it's an imaginary or complex answer. So we have plus or minus I square root of 15. And then last step, add 2 to both sides. So the solution for this would be x is equal to 2 plus or minus I square root of 15.
Made with Doodlecast Pro.